Hello and welcome. I'm Michael and I have a strabismic brain. I've been strabismic since I was 3 years old. And today I wanted to explain some concepts I learned while studying strabismus and the brain and vision. And today I wanted to talk about suppression, retinotopic maps, and the motor aspects of strabismus that might impede the proper development of retinotopic maps. So what are retinotopic maps? Recently I took a course on Coursera about space in the brain, and in that course at one point they explained what retinotopic maps actually are. And I thought the teacher explained it marvelously with this example. If you present the eyes with this image, then the physical location of the objects you see will be represented in a specific physical location in your brain. So if your eyes watch this bullseye, then the purple element will be represented on the purple element in the visual cortex. So your eyes perceive the light rays, then they get transmitted to the lateral genital nucleus in the thalamus, and later on they get transmitted exactly as they were received at the level of the eyes and the retina to the visual cortex. And visual processing is way more complicated than this, because there's also cells determining direction, etc., etc. But still I thought it was marvelously to see that the physical location of objects in the real world is still represented in your brain. And later on, once they are received at the level of the cortex, they get interpreted more widely through the where and how to stream, because there's actually two visual systems, and the what stream. So this pathway adds factual information like names, emotions, information about what is seen, and this pathway helps you to think about, to actually specify spatial vision. So where is the object in space and how can I interact with the objects? So this would be more likely to be useful while moving, doing sports, driving, and this pathway would be more useful when, for example, identifying a face. But obviously they never work completely in isolation, so you need to know where the face is and then identify it, or you need to, while driving, you need to look at all the elements in your view and then identify them so you won't run into them. And then a big player in integrating all this information is the somatosensory cortex, where, well, it's a bit simplistic, but where all the vestibular, visual, auditory, you name it, information gets integrated. But so what happens when you are strabismic instead of having just normal binocular vision? I thought about this, and I think so a lot of people, when they develop strabismus as a child, they will either use one eye or they will start to alternate between both eyes. So either one eye or the other, and they will never see with the two eyes simultaneously, but they will always use one or the other, and the other eye will turn in. So what happens to the retinotopic map? I think it's a theory, because I don't think it has been studied very elaborately, that your brain develops two independent retinotopic maps. So you wouldn't have this nice bullseye represented in the brain. You would have, when one eye is used, you would have one retinotopic map and the other one would be switched off because the eye is suppressed. And when the other eye is looking and the other eye is turned in, you would switch over to another retinotopic map. But then oftentimes when you have strabismus or binocular issues, one eye will be better at, for example, the where to, will be better connected with the where to or how to stream. So you will use that eye to maneuver, etc. But then the other eye will be better, will be maybe more dominant at reading, for example, because it needs to identify the characters, etc., etc. So in strabismus there's a lot of unnecessary trade-offs between one eye, the other eye, or for example spatial vision against object vision, and you will never have all the elements at one time. You will have to do things in sequence rather than instantaneously and simultaneously, and that's why strabismus is such a serious condition, because you don't have a nice overview, you don't have stereo vision, and you will have to, for example, when driving, it's good to have an overview and identify all the elements in your view at the same time. But if you have to do things in sequence, then you will have to figure out where are all the things, and then what are all the things, and then maybe it's too late already. But it's the same way with all other activities. But driving is more vital, but for example when doing sports or even reading, because you need to know where the character is and then identify it. So if you have to read, doing those things in sequence instead of simultaneously, then it will slow you down to a large extent, maybe twice the amount or more. You need a lot more time to get things done, and it makes life a lot harder, and it steals your effort and your time. So that's why when thinking about vision therapy, it's a lot about reverse engineering and trying to integrate functions you already have, but maybe you have to do them in sequence, but then you have to learn to do them simultaneously. So then things can be done a lot faster, and you can stop wasting your time on doing one or the other, etc. But obviously to integrate and to use both eyes together and to develop one nice unique retinotopic map, as is the case in normal binocular vision, you need to be able to align your eyes or to move them in a way that the locations on your retina will always be will always correspond to the locations in your visual cortex. And to do that, your eyes need to move seamlessly regardless of where you're looking, because if your eyes can't do it, then all of a sudden you have another retinal location for an object. So there's not only rivalry between both eyes, but also rivalry in the cortex, and then all the other adjacent functions that draw on this first source of information will suffer as well. So that's why it's so important to have good and reliable eye movements. I'm not even going to go into what it takes to have proper eye movement, because I took this image from a neuropsychology textbook, and these are all the brain areas involved in saccadic eye movement. So it's very complicated and very hard to understand, and even harder to explain. So I'm not even going to get into it, but it doesn't really matter how it works if you know how to do it. It's better to be able to do it than to know how it works. So when doing vision therapy, the first thing you should work on is getting your eyes to move properly, or simulate this correspondence between the eyes and the retinotopic maps with some sort of prism, if that's possible. So this was my first video about retinotopic maps, suppression and binocular vision. Thank you for watching, and I hope you learned something. Bye.